Alright, so if I'm doing the second method here, you are going to assign u equal to the little guy. So I still need to figure out what the little guy is. The little guy is this 5x to the third plus 1. So I'm going to say u equals 5x to the fifth plus 1. U equals 5x to the fifth plus 1. This is called u substitution. So again, typically when I do these, I don't do this method, but I'm also not in Calc 3 where you might need this method. So you can do whichever you want. I just want to show you the real process. All right, then find du. So du is the derivative of u. So du would be 20 x to the fourth, right? 25x, geez. 25x to the fourth. You can't expect me to know it all. Adjust du so that the left hand or the right hand side equals what is in the integral. That'll make a little more sense when I do it, I think. Just write it down for now. So what I mean by that is this is what's supposed to be here. So I need this to be 50x to the fourth. So what did I multiply by to make that happen? 2. Well, if I multiply the right-hand side of my equation by 2, I better multiply the left-hand side also. So now I've got 2 du. There is technically a dx over here, but I'm not too worried about that. Then, rewrite the integral with u. So, 50x to the fourth, and then the dx, is not 50x to the fourth and dx anymore. It's 2 du. Du, I'm just going to throw at the back. And this is no longer 5x to the fifth plus 1 to the negative fourth. It's u to the negative fourth. The hard part's done. I'm going to do more. Now I integrate this. So this is way easier to integrate, right? Add 1 to the power. Multiply by the reciprocal of the new power. So it's negative 2/3. And then you just put u back how it was. So what is u actually equal to? 5x to the fifth plus 1. And that's your answer. So we did the same thing, right? Like if we were doing it the way I showed you, I would have said, put a half here, because you got to make this 25x to the fourth. And then if you put a half on the inside, what would you have to do with the outside? You have to put a 2. Well, that's the 2 that we would have put there. Then you integrate the big guy. Like it's the same process, it's just formalizing it. Like I think it makes it harder, I'm not going to lie. And if you're going on in calc, you might want to get to know this method because this is what you use in college. So,
What happens if you use the other way though?
you just run to a point where you're like, I can't do this problem anymore. Is everybody still writing this one before I go on to like another example? You still writing? Or processing or whatever? Yeah. How are you doing, Zeller? Okay. Will your method work if there's a big guy, little guy, and a little guy?
What?
That's what's coming. I will see. So it'd be like the integral of 3x times sine of 6x squared. To the fourth. No, I can't do that. That's supposed to be 3. I don't know what it is right now. Alright, whatever. Alright, you get deeper right now. Is that good? Alright, let me do another one. This is definitely not like an intuitive way to do it. That's so I think mine kind of makes sense, like intuitively you can kind of understand it. This is more like just like doing it. Okay. So first of all, I would say we're just going to make it in powers instead of in radicals. So 2x to the fifth plus 3 to the 1/2 times dx. And then I set u equal to the little guy. So what is the little guy in this problem? 2x to the fifth plus 3. Then I'm going to take the derivative. So there's a real step. I kind of skipped this step. What's really happening is here, you're saying the derivative of u with respect to x is 10x to the 4th. Which means if I multiply both sides by dx, I get this. So take the derivative of u with respect to your x variables, 10x to the 4th, multiply both sides by dx, which just moves it to that side. Now, I've got 10x to the 4th times dx, but I'm supposed to have 30x to the 4th times dx. So what do I need to do to this side? It needs to be 30, right? So I need to multiply it by 3. Well, I better multiply the other side by 3 also. Now, I match up. So now I can do my u substitution. I can substitute u's into the integral. So instead of this, what do I have? 3 du. Right? I'm going to put the du at the back. Instead of this, what do I have? U. And then the 1/2. So the point of it is you're simplifying it and saying this is way easier to integrate. Let's make it easier to integrate it, and then plug everything else back in. So I can integrate this, add 1 to the power, which is 3/2. Multiply by the reciprocal of the new power, which is 2/3. So 2/3 times 3 is 2. Plus c. And then if you're doing this method, people have turned that in the gateway. You did a really good job, you did the whole problem right, but you forgot to plug back in the x's. So if I give you the problem in x's, you gotta give me your answer in x's. It's still wrong. So make sure you plug it back in. So instead of u, what am I putting? 2x to the 5th plus 3. You do or no? Should I do another one? You guys think no, like you're like opposed to it? You're like anti me doing more examples? You just want me to stop talking? You just want to check out? You just want me done? I'm doing another one. Damn it. The one I gave you? Oh no. I can't. I mean, I'll look in a second. But... Well, let's do this. Try 13. You guys try 13. Try it with the U method. Wait, show me like what you're doing.
Oh, well, literally just started off.
Well, how did you get the 5? What do you think? I mean, let's see.
Yeah,
That's
so
not
a lot more.
It's just like, yeah. That just gets like probably more complex. Higher levels. That'll run out of it won't function. Not this one. Not this one. So how'd you do the triple?
I really
So you big X. So that's what's 12. So you would like to go 1 4 with your method. Yeah, figure.
so that's
You got it. So you're doing the same thing, you're just like saying so much stuff.
basically.
We got 11:02 is what we got. I gotta wait. Don't put your stuff away, please. Like, why is that different? I'm not trying to say like that's a stupid question. I'm trying to see if there's something. Yeah. Okay, so if I'm doing 13, I set u equal to the little guy, so 3x to the 4th minus 1. du over dx is then 12x to the 3rd, which means du equals 12x to the 3rd times dx. But it's not supposed to be 12x to the 3rd, it's supposed to be 48x to the 3rd. So to make that happen, I gotta multiply by 4 on both sides. So 4 du equals 48x to the 3rd times dx. So instead of putting that, I'm going to put 4 du. Instead of putting that, I'm going to put u to the negative 4. Now that is a heck of a lot easier to integrate than this one. So add 1 to the power, multiply by the reciprocal of the new power, so negative 4 fifths. Oh yeah, my bad. Look at you, you're on fire, man. Add 1 to the power, multiply by the reciprocal of the new power, and then plug your x's back in, so 3x to the 4th minus 1. How many got to that with the u substitution method? Questions on it? So I'm just curious, like if I gave you, just, like, put all your stuff away, I give you a 5-question quiz, how many are you going to use that first way I showed you? How many would probably use this way?